All right, guys. Good evening again. We are continuing from where we left off yesterday. And today we are going to be looking at bearings. Now, bearings is another application where we can apply trigonometry. But in addition to just applying trigonometry, there are some rules that govern bearing itself, because bearing is a means of trying to find your location in terms of the globe, in terms of the world map. So to find your position on the globe, we have what we call bearings. That is a method that helps you to find your position on the globe. And as I said before, you can also apply trigonometry to bearings. So we're going to be looking at bearings today, and while we're going through the process of bearings, we're going to apply what we already learned about trigonometry as well. All right, so there are some things to note about bearings. So let us go through those first before we actually start to look at any of the questions. All right. So first and foremost, we say bearings is mostly used for navigation in respect to cardinal direction. Now, anybody familiar with the cardinal directions? What do you mean when we say the cardinal direction? Anybody know what we mean? Can I get a response from someone? Cardinal direction, students.
Sir, like north, south, east, and west.
Exactly. So when we are looking in terms of east, west, north, south, those are the four cardinal directions. And of course, we know that those positions would form right angle to each other. So you have a horizontal line and a vertical line. And so east and west is on the horizontal line, and north and south is on the vertical line. And so they are right angle to each other. And so if you consider a circle forming on the cardinal direction, so that the intersection is at the center of the circle, then we can easily measure angles right around that circle based on east, west, north, and south. All right. So we say bearings are measures of angles from the direction of a north line in a clockwise direction. Now, so it is a measure of angle. So that's what bearing is, but it is measured in a specific way. So you have to start with a north line. Remember, angles have to do with measuring the opening between two lines joined at a point. But for bearings, the north line has to be one of those lines joined at a point with the other line that we're measuring the angle. So it is always a measure from a north line. So you always have to have a north line. And you start your measurement from that north line in a clockwise direction. So it means that you're moving around, just like how you have the hands of a clock, moving around from the 12 going right round back, right back to 12. So it's the same direction we're moving in when we are measuring bearings. All right. All right. So that's what we say bearings are. These are the things to note. Now, bearings, well, this is restating the definition. So bearings are measure of angles from the direction of a north line in a clockwise direction. Now, when we write our bearings, remember, bearings is an angle, but we have a special way how to write these angles. We write them with 3 figures. So every bearings is written with 3 figures. So if you're looking at the examples that we have here, if we measure an angle of 7 degrees, if you're writing it in the form how we write bearings, it means that we have to have 3 figures. So we would have to start off with 2 zeros. So we would have 0, 0, 7 degrees. So that is an equivalent angle of 7 degrees. All right, but in bearings, you write it with 3 figure. And if you want to write the bearings of 86 or an angle of 86, we have to write it in bearings of 0, 8, 6. So wherever, depending on your place value, so if your place value would be in the ones column, then you would have to fill in the tens column and the 100 column with 0. If you have 2 place values, 8 and 6 here, and 8 is in the tens and 6 in the 1, then you have to fill in the 0, the 100 position with a 0. All right, guys, so that's one of the rules when we're writing bearings. All right, to find the bearings of B from A. Now, when we refer to B and A here, we're referring to these as points. So if we have B and we have the point A and we get a statement, find the bearings of B from A. Now, that statement must be interpreted in a particular way. So what you want to determine B from A, you want to know which of these points we're going to start off with. Are we going to start off with the B, or we're going to start off with the A? Now, I underline from A. Now, from A tells you the point at which you're measuring the bearings, right? So if you're measuring the bearings from A, it means that you're going to start off with the point A, and then you're going to draw a north line to that point, and then you measure your angle in a clockwise direction from that point. Now, remember now, you would have a point, just to illustrate what I'm saying. So if this is the point A, use another color. All right, so if this is the point A, and so we're measuring the bearings of B from A, then clearly we're going to draw a north line to A. So whichever letter comes after the word from, you're going to draw a north line to that point. So it means then we would have to draw a north line to the point A because A comes after the word from. Now, our north line is generally a broken line in terms of a dotted line, but in this case, I'm just using a solid line just for illustration purpose, all right? So your north line should be a vertical line. Now, above that line, you should label it with an N to mean you're at north. So it means that you're going from A to north with this line. So you label that point above A, or an arrow above A, you label that north. All right, so that's what this from A means. You start with the point A, you draw an outline to A. Now, remember now you're measuring the bearings, you're finding the bearings of B. So it means that there has to be a point B so that when you connect A to B, you get the line AB. So if B is at this point, so here B is at this point, then now you have to connect that line A, connect the line from A to B. And so when you do that, now you'll get the line AB. Now you need to know, you need to have this line so that we can measure the angle between the north line and that line. You see, remember, we can't measure angle by using one line. We have to use two lines. And the two lines join at a point, and then the opening at that point is what we measure to give you your angle. All right, so once we have drawn the line AB, then the next thing that we have to do now is to measure your bearings in a clockwise direction. So if you notice that the arrow is pointing in the direction coming from the north line to the line AB. So that is where you would have to measure the angle. Now, for our purposes, we will find ways of calculating those angles. So we may not actually use a protractor to measure the angle, but we may use our knowledge of trigonometry to calculate those angles. All right. So that's part of what we'll have to be able to do when we're doing bearings. All right, so that's what this third point means. So to find the bearings of B from A, then we have to draw a north line to the A. The A comes after the word from, so we draw a north line to that point. And then now, wherever B is at that point, you draw a line from A to B. Then you measure your angle from the north line to the line AB. All right? Is that clear to everybody? And you have to do it in a clockwise direction. All right, so with that said, let us look at the next point. So the next point is that remember that north lines, you may have more than one north lines depending on what the question is asking you for. But when you have more than one north lines, you have to remember that these north lines are parallel. And if does anybody know what it means for two lines to be parallel? Can somebody give me a description of parallel lines? Hello?
Sir, they're running in the same direction, or you'd say side by side.
All right, so and so if we have two north lines, and as you say, Miss Wilson, if they're running side by side, then one of the important thing about parallel lines is that they maintain the same distance between them, no matter how far they go. So if the distance between them is say X, they travel throughout their distance beside each other, maintaining that distance X between them. All right? So that's what we mean by lines that are parallel. Now, another way to think of parallel lines is that they never diverge away from each other, and they never come to a point. So they never diverge and they never converge. Now, what that means? Now, for lines that diverge, if we have a line, we have two lines that are divergent, it means that they are not parallel. And if they are divergent, it means that they are going away from each other outwards, right? So it means that if you put an arrow on this one, another arrow on this one, you'll realize by them going in that direction, they are spreading apart from each other. So they will never meet, right? So we say that they are diverging. Now, if we have two lines that are converging, then it means they are moving in such a way that they may meet at a point. And so lines that eventually meet at a point, we call those convergent lines, all right? So when lines are parallel, they don't diverge and they don't converge. And so they will never meet at a point and they will never go away from each other. Is that clear, guys? Guys, respond to my question. Is it
Yes,
clear?
sir.
Yes, sir.
All right.
Yes, sir.
All right, so with that said, these are the things that you must remember. Now, why is it necessary to remember that north lines are parallel? It is necessary to remember that because there are times when we may rely on the fact that we have two north lines that are parallel. And how this can help us is that we may find that we have a line going from one north line to the next. And if that is the case, then because these two north lines are parallel, what you think will happen with the angles that this line that is connecting the two north line, what do you think the angles, the property of the angles there would be? What property of angles that will come out from a line crossing two parallel lines? Anybody remember anything about Z angles? So if you
Sir,
have
can you repeat?
I'm asking what property will come out regarding the angles formed by a line intersecting two parallel lines. So let's say that this line here is crossing the parallel lines. That means they're cutting them across. What can we say about the angles formed by that line? Anybody? All right. Let me draw another diagram for you.
They are equal.
All right. What the angles would be equal?
Yes, so the measurement of the angle will be equal.
Why would they be equal? What property? All right, let's say we have two parallel lines going horizontal. And then now we have a line that cross both of them. What angles can form from the two from the line intersecting the two parallel lines? Now, what property you know about these angles here? What we generally call these angles? And Dorothy said that the angles are equal, yes. So if this angle is X, or let's say that is alpha, then this is also alpha. But in math, we call this angle by a special name.
Is it acute, sir?
Well, the angles are acute, but we refer to them based on the fact that they form a letter.
Oh, the Z.
Right, so we call them Z angles. So once you have two parallel lines and you have a line cutting them, you have to look out for Z angles because Z angles are equal. Now, when we refer to Z angles though, it doesn't mean that it has to be in the same formation of a Z for them to be equal. Now, we know that this angle here, if we call that theta, it will be equal to this angle here, which is also theta, because those two angles would be in relation to the Z that we form this way. However, these angles behind here are also Z angles in a sense, but it would like the Z run in an opposite way. It's more like an S instead of a Z. But these angles share the same property too. They will also be equal. So if this angle is phi, then this angle is also phi. Is that clear, guys? And so for this reason, we say that you are to remember that north lines are parallel. And so you may have lines crossing them that may form Z angles. So that is something for you to bear in mind when you're doing bearings. All right, guys, is that clear to everybody? Raise your hand if you are clear with what I'm saying, guys. You know, I like when you're responding, because when you're responding, that indicates to me that you're understanding. All right, so moving along then. So just to quickly go back through these things to note so that you bear them in mind. So we say bearings are measures of angles from a direction of a north line in a clockwise direction. So you always have to have a north line when you're measuring bearings. The second thing to note, the bearings are written in 3 figures, 3 digits when you're writing bearings. The third point is that to find the bearings of B from A, then whichever point or letter that comes after the word from, that's the point you draw your north line to, or that's the letter that you're going to draw your north line to. All right. And then now, after you draw your north line, then you have to draw another line from the same point A, connecting the point B in this case. All right, so the fourth point is to remember that north lines drawn through separate points are parallel to each other. And as I've just explained to you that they will allow you to find Z angles. All right, so moving along. So here we have a question relating to bearings. And so we have to read through the question carefully. And just as before, as we were doing angle of elevation and depression, we should be able to construct a diagram based on the given information, right? Because, so that is one skill that you need to develop to be able to read the question and draw a diagram. So that will help you. Now, before I actually go through this with you, I will ask that you try to figure out in your mind how you can construct this diagram. So I'm going to ask somebody to give me an idea how they would actually construct the diagram based on this question. So let me read the question and then now you think about how to draw the diagram. So B is a point due east of a point A. B is a point due east of a point A on the coast. Now C is another point on the coast and it is 6 kilometers due south. Now C is another point on the coast and it is 6 kilometers due south of A. All right. The distance BC is 7 kilometers. So you have to calculate the bearings of C from B. All right, with all of that said, anybody care to take on the challenge of drawing a diagram to represent this information? And as you draw, you explain why you draw it in the way that you're drawing it. Mr. Lamar, you seem to be the person dealing with diagrams. So let us start off with you.
Sure.
Yes.
Mr. Administrator, may I get the one in?
All right. So what we do when we're drawing this diagram, start off with the first sentence and see if you can construct something based on that first sentence. And then you read the other part or the other sentence, construct something else.
Okay, sir.
Right. So the first sentence here would be B is a point due east of a point A on the coast. So what do we know? We know that we have a point B, we know that we have a point A, and we know that B is east of A. So what can we draw now to represent that?
So you can draw point A or point B. So draw point A first. Draw A.
All right, so if we start off with A, why are you starting off with A?
Sir, because it says point B is east of A, and I'm doing it from left to right.
All right.
And east is to the right.
So, all right, so that is good that you know what point to start off with, because that is often confusing for students. So here we have A, so where would we find B? Where would we find B now?
So to the right of A.
All right, so if it is east, it has to be on a horizontal line
Yes, sir.
to the right. So let's say that B would be right here. All right, so what we need to do is to just connect these dots now to form a line AB. All right, so we will just connect the point A with the point B.
Yes, sir.
All right, so that's the first thing that we have done here. So
Yes,
next,
then it says another point is C, which is south of A.
all
So you
right,
draw a vertical line, which is downwards from A.
all right, so now we need to find C. So we know that C is south of A. So it has to be on a straight line from A going downward.
Downwards.
So C could be somewhere down here.
Yes, sir.
All right, so let's call that point C. So the next step now is to draw a line to connect those points. All right, now the fact that one line is horizontal and the other one is vertical, what that tells you about the angle formed at A?
90 degrees.
Exactly, so it means that at A, you're going to have a 90 degrees right here. Everybody agrees with that? And so that is important because remember now, if we are applying trigonometry, we may want to identify right angle triangles and so on. All right, so that would have been the second sentence in the question. So what next now, Mr. Lamar?
So it says the distance from B to C is, so it says the distance of BC is 7 kilometers. Calculate the bearing from C from B.
All right, so we know that distance BC is 7 kilometers. So we can draw a line to represent BC.
Yes, sir.
All right, so a line from, all right, so we would have a line like that. All right. All right, so what next?
Try to do some stuff now.
So it said calculate the bearings of C from B.
From B.
Now, remember what I was saying earlier on, that the letter that comes after the word from, or the point that comes based on that letter after the word from, would be the point B.
Yes, sir.
And that is the line that we must draw our knot line to. Or that is the point that we must draw our knot line to. Is that clear?
Yes, sir.
All right, so it means that from the point B, we have to construct a knot line. And remember I said to you that this should be broken line, because your knot line is not a solid line, it's actually an imaginary line, so it must be broken. Trying to see if I can get it to look broken. All right, so it means that our knot line going to be going to the north. And so that this would give you a knot line. And so you label it above here as north.
Yes, sir.
All right, so here we have our knot line. And now we're calculating the bearings of C from B. Now remember, our bearings must be an angle measured from the knot line in a clockwise direction. And because we're measuring the bearings of C, it means that we have to draw an angle from the knot line to the line BC. All right, so the angle